Okay, so this class, Marine Science 210, is an introduction to non-science majors on the importance of the oceans and how we as humans interact with the oceans. Now, one of the requirements for this class is this book, Oceanography by Dr. Garrison. It's the 10th edition. But one thing I want to point out is you can use any edition, quite honestly, after the 7th. So this is my copy of the 7th edition, up until the 10th. So this is the newest one. I actually don't know if it's available yet. I think this is a preprint, but they're essentially all the same in terms of order. So if you have any questions about the textbook, please let me know. But one thing I want to do for this class is also provide a little more information on terms and definitions. And so the way I'm going to do that is I'll have a video for each chapter. And so this particular chapter is chapter 1. So we're going to just touch on a few terms here. And before I get started, the ones in yellow, there's 5 of them here, are the ones that are really important. So I definitely want you to understand and know those 5 definitions, but we'll go over each of these and we'll talk about which are important, which aren't so important. Okay, so chapter 1, terms and concepts. The first term here is accretion. Accretion is just an unnecessarily fancy word to mean combining. That's really all it is. And so accretion in this context is combining primarily rocks, hot molten rocks, and dust into Earth, right? Earth was created by combining all of these things. When we talk about Earth and the origin of Earth and everything else, that's often referred to as the Big Bang. The Big Bang was, I believe, about 14 billion years ago. That's what you need to know about it. That was the origin of it all. Right? So when we talk about oceans, that's the beginning. Biosynthesis is, again, a very unnecessarily complicated word to essentially meaning creating things through biology. So usually not artificial, but usually in a lab setting. And so the example of that is if you want to biosynthesize molecules of life, you can do that in a lab. That's all that term refers to. Condensation theory is a theory about the origin of life on Earth, where materials were concentrated through condensation. And so an example of condensation, again, a very complicated word for what it's trying to get across to you, is if you've ever been in a car or a house that's warm inside, but it's cold outside. What happens is as you breathe inside the house and the car, you're exhaling warm air that has water in it. And what will happen is that warm air with water will interact, touch a window, a wall that is touching the outside, which is cold. Because of that temperature difference, you're going to get condensation. And what that does is you get little droplets of water. The same kind of idea happens, or is thought to have happened with life on Earth, in that you have condensation or concentration of materials. That's all that is. Density is a term to describe, how do I put this? Density is a term to describe essentially kind of how light or heavy something is on a specific area. And so I say specific area because you can think of like cubic centimeter, right? So if you take a centimeter and you make a cube out of it, it's about this big, right? It's like a sugar cube, right? That's essentially a square centimeter. Now, a sugar cube is made out of sugar, right? It's some material that has some density. Now, if you take that same sugar cube and instead of sugar, you make it out of lead, lead is more dense than sugar. So it will appear heavier, which it is. Or if you take that sugar and you replace it with something like I'm trying to think of something, water. So let's imagine we have a cube of water. Depending on how salty that water is, you can make it different densities. And that's what we're going to talk about in this class. So that's density. But also density is important for a term called density stratification. And this is an important term. So if you think about, this is a bad example, my cup of coffee. I would never do this, but I have a cup of coffee. And imagine I take an ice cube and I put it in my coffee. What would happen to the ice cube? Well, it would float, right? All ice floats. The reason it does that is because of density. When we say density stratification, if I take an ice cube and I put it in my coffee, and I also take sugar and I put it in my coffee, the sugar falls to the bottom, right? Because it's more dense. The ice floats because it's less dense, right? So I have a stratification, strata, layers. So I have ice, coffee, sugar, right? That's density stratification. And that is essentially how the Earth works, right? Where we are on land, the air is less dense. If you take a rock, and you drop it, it's more dense than air, right? And if you keep going to the core of the Earth, it is much more dense. So the core of the Earth is the most dense part. And as you go out, it gets less and less dense. This is density stratification. Next term is experiment. Experiment is how we do science, right? So if you have a question like, why is this like it is? Why does this go there? Why is this thing found here? You can design an experiment to understand that, right? To ask questions. Galaxy is a term for where we exist. The one that we exist in, I'll skip ahead a little bit, it's called the Milky Way, right? That's our galaxy, right? We're a universe in this galaxy. I'm not an astrophysicist, so I'm not going to talk a lot about kind of space because it's kind of beyond my understanding. So if you're really interested, there's a really good person called Dr. Neil deGrasse Tyson. He has a series called Cosmos. He's an excellent person to explain the relevance of the intricate details of galaxy and how it fits with us. For us in this class, the galaxy is where Earth exists, and our galaxy is the Milky Way. Not all planets are like Earth, right? So Earth, we'll skip ahead a little bit, it's called a terrestrial planet, right? We have land. There's also other types of planets called gas giants, right? They're just big balls of gas. It's just a different type of planet. A hypothesis is associated with that experiment we talked about before. A hypothesis is something that we test. So if we say, you know, I wonder why this crab is only found here and not there. That's the hypothesis. And I can do experiments to find out why this crab is here and not there, right? Maybe it's because over there, there's a bird that likes to eat that crab, or maybe it's too cold, or maybe it's too salty, right? You can design experiments to ask those questions, right? But the kind of the way we ask questions in science is called hypothesis. Now, once you ask a lot of hypotheses and do a lot of experiments, you start to understand more about how the system works, right? So if you think about gravity or, you know, how the planets orbit the sun, right? Things like that. Those become laws, and there's very few laws. I can't remember how many there are. There's not very many of them, which means I should know them. But there are certain laws that have been established in science over time. Marine science, It's a special type of science that has to do with the ocean, the creation of the ocean, how the ocean moves, why the ocean's salty, what lives in the ocean. It's a very broad area. So marine science. Also oftentimes called oceanography. So, you know, if you look at this book, it says oceanography, right? It's essentially marine science. It's the same term. Milky Way, talked about this before. That's where we are on Earth. Nebula is a feature of the universe. There's a lot of different nebulas. There's the Crab Nebula. There's I forgot the name of the other one. There's a variety of different nebulas that exist. They're a feature of the universe. That's essentially what I want you to know. Ocean, a body of water that has salt, right? And this is different from a body of water that doesn't have salt, right? We call that a lake, right? Ocean's body of water with salt. Oceanography, I mean, essentially marine science. It's the study of the ocean. Outgassing is anytime something gives off gas. So for example, a good example is plastic, quite honestly. If you get a new piece of plastic, like a piece of plastic that was just made, right? Like a tire or like, you know, a plastic box or whatever. Right after that plastic is made, it gives off gases, right? It outgasses. And the Earth as a planet did the same thing, right? It outgassed. So as the Earth was created, gases were released. Planets, I mean, they're typically, not always, terrestrial. You have some that are called ocean planets, which we'll talk about more. You have gas planets. They're essentially concentration of materials in the universe, right? Could be rock, could be gas, could be water. That's essentially a planet. Science. Science, what is science? I should know this. It's essentially the study of how things work, trying to understand how things work. It could be biology or chemistry or geology or physics. Like, why do things do what they do? That's essentially science. The way we ask questions, we talked about hypothesis and experiment earlier. This is part of the scientific method, right? Because you don't do one experiment and then you're done, right? You do then experiment and then you're like, my hypothesis was maybe I want to change it a little bit now, which happens all the time in science, right? Because you have more information. Well, maybe that crab isn't here, not because of birds. Like, I don't see any difference in terms of birds. Maybe it's something else. Maybe it's the salt. Maybe this is too salty and that's not salty enough, right? You can change and evolve your hypotheses. And this is all part of the scientific method. Solar nebula is a specific type of nebula. That's all you want to know about that. Solar system is where Earth is located, right? At the core, the center, what we all rotate around, Earth, Venus, Mars, all the planets all rotate around the sun, right? Solar, right? They rotate around the sun. That is our solar system. Stars, stars are complicated. What you look out in the night sky and see, lots of different things. Galaxies, nebulas, planets. Depending on how far away they are, they can appear to be stars. Supernova is essentially a star, a giant star, exploding like a is supernova, right? Huge explosion. This is important because a lot of things that we're going to talk about, like chemical elements, were created during supernovas. Terrestrial planets, we already talked about, like Earth, Mars, right? Venus, those are terrestrial planets. A theory is anything that, there's what's a good theory? Gravity. Gravity is a theory, right? So, you know, I can drop this rock 1,000,000 times, and every time it should do what? Fall, right? Because of gravity. But imagine if I drop the rock and it just floats there, or it goes up or sideways, right? A theory is what is when you're pretty sure about a hypothesis. I'm pretty sure gravity will cause things more dense to fall. Right? That's all it is. All theories come, sorry, all laws come from theories. And it takes a lot of understanding and science and experiments and hypothesis to develop laws. And a lot of things we think of as laws are not actually laws, they're theories, right? So think about evolution. We'll talk about evolution like, you know, evolution happens, right? But it's not a law. We're pretty sure how things work, right? We've been studying evolution since the 1860s, right? We have a pretty good understanding of how it works and what factors are involved, but it's not a law. And then finally, world ocean. A lot of people talk about the oceans as the 7 seas, and you can split up the oceans, but quite frankly, I'll show you a slide of this in class. It's one ocean. They're all connected, right? So it's called a world ocean. Okay, so that's it for chapter 1. So hope that was helpful. And if you got any comments, please let me know.